The next section of sample test 3 all revolves around the use of this table. Hopefully, again, you got this when you were in class, when we got back from spring break. If you weren't able to attend any of those classes, make sure you're printing this out. It's absolutely available online. Make sure you have this table when you're attempting any of these problems. Question 3 on the sample test asks, what's the probability that z is greater than 1.18? First thing I need to do, make sure I'm on the right side of the table. The side with the graph at the top is negative z-scores. The side without the graph is positive z-scores. Since this is a positive 1.18, I'm on the side without the graph. I start with the first two numbers, 1.1. I go down the left side until I get to the row marked 1.1. I then use the remaining digit, 0.08, to tell me what column to go over to. When I move over to 0.08 and I line up the row 1.1 with the column 0.08, I get a z-score, or I'm sorry, I get a p-value of 0.8810. So far all I've done is taken the z-score given, looked it up in the table to find the table entry. If this had said less than, I could stop there and that would be my answer. Because this says greater than, to get to my final answer, I need to do 1 minus 0.8810. I get that to be 0.1190, which is my final answer. For question 4, it's the same general idea. Difference being this less than sign means it's going to be slightly easier. I'm just going to have to look up in the table 1.88 and then report whatever I get as a p-value. So again, I'm on the positive side. 1.8 is my row. I move over to the 0.08 entry and I get 0.9699. I can stop right there because it's a less than question. For a between question like this, I'm going to need to get two p-values, take larger p minus smaller p. So I start on the negative side with negative 1.48. I go down to the row negative 1.4, over to the column 0.08, and I get a p-value of 0.0694. For 0.65, I'm going to need to be over on the positive side. I'm going to start with the first two digits, 0.6. Once I found that row, I'm going to move over to the third digit, 0.05. When I line up 0.65, I get a p-value of 0.7422. If you're ever confused which one you're subtracting from which, remember, you must get a positive answer for any probabilities. Probabilities are strictly bounded by 0 and 1, so I can't get something less than 0 and negative. I can't get something greater than 1. For that reason, it's always going to be bigger minus smaller to make sure that I can't get something less than 1. So if I take 0.7422 minus 0.0694, when I put that into my calculator tells me 0.7422 minus 0.0694 will get me to 0.6728. Those are the problems that just deal with having to use the table, knowing how to find z-scores, and how to either take the probabilities you found and change them into greater than by doing 1 minus, leaving them as less than by just reporting the p-value, or using two different p-values to find the area in between by doing larger minus smaller. The next two problems ask us to use the table in reverse. So when I say the table in reverse, instead of starting on the outside and tracing to a p-value, we're going to start in the middle at a p-value and trace outside to a z-score. Specifically, in question 6, it asks me to find the 85th percentile. So I need to know that to change 85th percentile to a decimal, it would be 0.85. And then since our table's always 4 digits, I'm going to put a 0, 0 there to find what I'm looking for. Again, I'm not going to the 0.8 row. I'm not using the outside to find this. I'm starting inside and tracing back to the outside. So my first decision is, am I on the positive side or negative side? The negative side includes all probabilities between 0 and 0.5. The positive side includes all probabilities between 0.5 and 1. Because 0.85 is between 0.5 and 1, I know I'm on the positive side of the table. As I read down the first column of values, the column marked 0.00, it starts at 0.5000, then goes to 0.5398. I'm going to continue reading down that column until I find something larger than 0.8500. It happens when I get to the row 1.1, where that entry is 0.8643. That tells me the 0.8500 entry had to happen the row before. So as I read across that 1.0 row, in that 1.0 row, I see that it goes from 0.8485 to 0.8508. This happens, again, in the 1.0 row when I move between the columns marked 0.03 and 0.04. This is a case where I really could choose either of these two z-scores. When I look at it, this is off by about 0.15 or 0.0015. This is off by 0.0008. So this is technically closer. That's why I think that's what Cengage is going to want. And I choose the z-score 1.04. So the correct answer to the question is z equals 1.04. Normally, when I give this as an actual paper test, I say that I'd accept either answer, 1.03 or 1.04. My guess is that for this actual online test, if you put in the other one where it jumps over, I'll go back, be able to look at your wrong answer, and give you a correct answer for it. So really, the table that they're using in Cengage is more attuned to more decimals than 2. Again, this would be marked right for either of these if it was a paper test, so I plan on this question going back and giving you credit for it if you pick the other of 2. But the only possible correct answers are 1.03 and 1.04, where it jumps over that 0.8500 we're looking for. Question 7 is going to be more direct because it asks for an exact p-value. That's one that we know is going to be in the table. So when I look up that p-value, 0.9306, the same way I did before, starting on the positive side because it's between 0.5 and 1, going down the left-hand column till I get something greater than 0.9306. I see the row 1.5 is something greater than it, so I go back to 1.4 row. As I read across that 1.4 row, I see that 1.48 is where 0.9306 is happening. So my answer here is z equals 1.48.